Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks.
Hi, today I am going to start new playlist in my channel, that is plastic component design. So today's topic is introduction to plastic component design. Here I am going to explain injection molding process, molding principle, plastic component anatomy, and also I am going to explain how to create plastic component with the different methods in SolidWorks. So injection molding process. Here the raw material, so it will be in small granular size and sometimes it is called pellets. So this material, raw material, is poured into the hopper. The V shape is hopper and it is poured into this hopper and runs through the screw conveyor. Screw conveyor generally pushes the material towards the mold. These two are heating devices, and the center part which is in screw form is called ram, injection ram. And here the light blue color is mold cavity. It will be in a cup shape, so where the material fills inside. And the other dark blue color component is movable core, which is a male part. So this is usually a movable part which moves towards the cavity and finally it closes the loop and the material, hot material, is filled into this cavity. So finally, once it is cooled, it forms a plastic component. Left side you can see the final component. So this is the basic principle of injection molding process. So how does it works? So simple concept is there will be a cavity plate and one core plate. It moves towards the cavity and the material is pushed through sprue. So I am going to show you in 3D model. See here you can see so this is the plastic component. So the core moves inside and material is filled and the plastic component comes out. See here, the core part moves outside and the component is pushed here. See here, this component is formed here and it moves outside and the component is moved outside. So the red color portion is sprue part. The molten plastic material is filled through this gap. So that is the molding principle. And next is injection mold design. This is a separate segment. The mold designers are different from industrial designers and mechanical designer. So usually in product design process, industrial designer makes the concept of the product and it comes to the mechanical design engineers, so who usually works on SolidWorks and other CAD softwares. So the mechanical designer develops a plastic component. So the mold designer will take this plastic component, design a mold, the similar kind of mold as shown in the image. He designs based on the component. So design changes from the component to component based on the requirement. So this mold design consists of sprue bushing. Here is a sprue where the hot material flows into the cavity, stripper plate, cavity. This is the cavity where the material is going to fill. Component, see the green color, the material the plastic component, and this is the core. The male part is core. Ejector pins to push the component outside. Small puller pin, lower plates, bottom plates, and core plate, die locker, cavity plate, upper plate, and locking ring. So these are the components of the mold design. So as a designer, mechanical designer, we should have knowledge on mold design, what are the major components of the mold, and we should understand what is undercuts and where to use side cores, because when we design a component we should have minimum knowledge on the mold design, otherwise we cannot develop any concept on plastic components. So as a mechanical designer we should have minimum knowledge on mold design. Now let's come to the plastic components anatomy. So when we design any plastic component, so this is the one of the example I have taken. So when we design any component, it should have uniform wall thickness. The side wall should have uniform wall thickness. So like in sheet metal, we consider gauges. Similarly, we should maintain uniform wall thickness to avoid shrink marks. If it is not having uniform wall thickness, when we add any kind of ribs, these kind of features, there will be a depression over here at this location because of non-uniform cooling. So uniform wall thickness is important in plastic components. Now stiffener. Stiffener is to increase the strength of the component. Suppose this thickness is not able to sustain the loads, then we have to add these stiffeners or gussets. Next, boss. Bosses are usually for fastening the screws or supporting any PCBs. Ribs. Ribs are to improve the strength of the boss, because strong boss is like a pillar, and sometimes there is a possibility of breaking, so we add ribs to the boss. And fillets to avoid the sharp corners and stress concentration, we add the fillets. So these are the major features of the plastic components. Still there are many features of the plastic components which I am going to explain in the future video. So next, there are different methods to create a plastic component, but basically we follow two methods. One is from solid model to shell and creating a plastic component. So I am going to show you that example. See, I have created a simple sketch. Now I am going to create a simple revolve feature. Now this is a solid body. So if I want to create any plastic component, I should have uniform wall thickness. So here I am going to use shell. See here, for better understanding, I am taking 10 mm. Usually it will be less than 5 mm. So for visibility I am taking 10 mm. See, this is a uniform wall thickness. So this is one of the methods. So creating a solid body and finally creating shell. Later we can add any features like ribs, gussets, boss, and any kind of features. So this is one of the method. The second method is creating surface and creating a plastic component. Now I am going to surface module, creating a revolve surface. Here I am selecting the vertical axis. See, okay. See, this is the surface model which is having zero thickness. There is no thickness to this surface. Here I am going to surface module and selecting the thicken feature. Say okay. Here also for better visibility I am taking 10 mm. see. Okay, see, this is the other method. So we have two methods. One is creating solid and applying shell on this feature and creating a plastic component with a uniform wall thickness. Other one is creating a surface with zero thickness and adding a thicken feature to the surface and creating a uniform thickness to this feature and creating a plastic component. So these are the two methods. So in upcoming videos I am going to explain design guidelines of plastic components, as well as I am going to add more examples on plastic components. So don't forget to subscribe to my channel, and would request you to follow my channel. Thank you.